This is Ham College, episode 86, for February 28, 2022. Ham College is brought to you by ICOM. ICOM's new ID52A Handheld is the perfect radio for working your favorite bands inside the ham shack or venturing out. Hi, welcome to another episode of Ham College. I'm Professor Thomas.
And I'm Dean Martin.
And we've got some tough questions for you tonight on the Amateur Extra exam.
Oh, that is an understatement.
Yeah.
There will be buzzer tonight, I promise you. It has to be.
Could very well be. Could very well be.
If there's no buzzer, I'm going to buy a lottery ticket because this is going to be my luckiest day ever.
Anytime we're streaming a show live, we've got a chat room going on at the same time. If you're watching live in YouTube right now, the chat's right there. That's where we're at. You can pop that out on your browser and get it in a separate window where you can slide it around if you'd like to. We'll be watching the chat room tonight. You can submit the answers as we go along. We're not grading you, but we are looking at your paper.
We're looking over your shoulder, too.
Yeah, just to see, to get an opinion of, what everybody thinks the answer might be. And sometimes they get the same wrong answers as us. So what did we talk about on the last show?
Last show? Let's see. Well, the last show we did AC and RF energy in real circuits. We talked about the skin effect, electromagnetic fields, reactive power, power factor, electrical length of conductors at UHF and microwave frequencies, and microstrip.
Okay.
That was a lot.
That was. This month we're going to talk about semiconductor materials and devices, germanium, silicon, P-type, N-type, transistor types like Npn, PNP, junction field effects transistors, enhancement mode, depletion mode, MOS, CMOS, N-channel, and P-channel. That's a lot to stuff into only 12 questions because that's all that's in this part of the exam.
Yep. Oh, is it? I hope good, because that means next month we won't have more of those.
No, it'll be something tougher next month, probably.
Yeah, it probably will, because when we did those others like 2 months ago, I was like, that is the hardest ones ever. Yeah. But they weren't.
No, they continue to get harder.
Yeah.
So I guess maybe we should get on into them now and just see how things work out tonight.
Okay, here we go.
Yeah. Call it.
Heads. Okay, I'll take the first question. I'll answer the first one.
Okay. In what application is gallium arsenide used as a semiconductor material? Is it A, in high current rectifier circuits?
B, in high power audio circuits?
C, in microwave circuits?
Or D, in very low frequency RF circuits? Gallium arsenide. That sounds like some kind of poison.
Yeah.
Arsenic mixed with insecticide. Gallium arsenide used in a semiconductor material. I have no idea. I think that's going to be my answer for most of these tonight. I have no idea.
I don't see that as an option.
I really have no idea, honestly. The only one of those that stands out to me as it seems like it might need some kind of something special would be microwave circuits because of the really high frequencies for microwave.
So you're saying one of these things is not like the others.
That's what
Is
I'm
that
saying. And I'm thinking it's C because of that.
Okay.
But it seems like the other three would, like, I don't think there would be anything special about those. So,
Chat room majority says C. I'm going to agree with you. It's C. In microwave circuits. Now, I'm not sure if your reasoning for coming up with that is good or not.
I have no idea, man.
But it worked. It worked for you.
Yeah, well,
So.
that's probably not going to work all night, but we'll see.
All right.
We'll see. See what I did
I see
there?
what you did.
See what I did?
Yeah.
Which of the following semiconductor materials contain excess free electrons? A, N-type.
B, P-type.
C, bipolar.
Or D, insulated gate. Which of the following semiconductor materials contain excess free electrons? Well, let's see. Electrons are a negative particle. So I'm going to say it is N-type, which is right the opposite of P-type.
So the N stands for negative?
Yeah. And it wouldn't be bipolar because that would be going both ways. And insulated gate, that just doesn't have anything to do with it. I'm going to say it's A, N-type.
Looks like there's a lot of A's.
Yep, a lot of A's in the chat room. So
you nailed it. Here, I'll give you an N for nailed it.
Okay. All right. Well, I've got another one here.
That's what I was afraid you were going to say. And we're just getting started too, really.
Oh, yeah. Yeah. Why does a PN junction diode not conduct current when reverse bias? A, only P-type semiconductor material can conduct current.
B, only N-type semiconductor material can conduct current.
C, holes in the P-type material and electrons in the N-type material are separated by the applied voltage, widening the depletion region.
D, excess holes in P-type material combined with the electrons in N-type material, converting the entire diode into an insulator. Oh Lord, I should have called in sick and see if the assistant dean could have sat in for me tonight.
Yeah. I mean, generally cheap.
Generally cheap. Yep. Okay. This is a PN junction diode, not conduct current when it's reverse biased. P-type semiconductor material. Only N-type semiconductor material. Holes in the P-type material and electrons in the N-type separated by the applied voltage, widening the depletion region. That seems plausible somewhat, even though I don't fully understand it, but I kind of understand the principle of what they're saying. Excess holes in P-type material combined with the electrons. I'm guessing C. This is another one I don't know the answer, which I'm telling you is going to probably be my answer for almost all of them tonight.
C?
Yeah. C. That was my answer on the last one.
Well, the chat room is all saying it's C.
Well, let's see.
And it is. Well, it just so happens.
Oh, where'd you find that?
I've got some photos here. Well, this is not really photos. This is a drawing. On the top there is just, roughly what a diode's made out of. PN junction diode is a P-type and an N-type junction.
Mm-hmm.
If you put current on one side of a diode, it will come out the other side as long as you put it on the right one. If you didn't, it's blocked.
It blocks
it can only flow one direction.
Right.
where the P and the N type silicon touch up against each other. I won't use the word combine, but you can see right there in the center of the drawing where I've got depletion region, where those two meet right there. The holes in the P-type material and the electrons in the N material are separated, or that depletion zone there widens if you reverse bias the diode. If you forward bias it, current flows on through.
How about that?
Well, that's good because I really didn't have anything else that I could say about it.
I'm telling you, this is some tough stuff, man.
It is. It's some tough stuff tonight. So we'll move on to the next one here. And, this is one you're going to ask me.
What is the name given to an impurity atom that adds holes to a semiconductor crystal structure? A, insulator impurity.
B, N-type impurity.
C, acceptor impurity.
Or D, donor impurity. What is the name given to an impurity atom that adds holes to a semiconductor crystal structure? All right, so they put some impurities in the material to
intentionally
to cause it to accept electron flow. I'm going to say it is C, acceptor impurity. The chat room saying it's C. I think they have found the study guide.
They see the light.
Yeah. They see the book.
So far,
I don't know.
So far, they've all been C.
Well,
most of them.
Yeah, you're right. And this one too.
But when you go take your test, don't go by them all being C.
No, that won't really work out that good for you. All right.
Arnie said, I may want to surrender their extra class license.
How does DC input impedance at the gate of a field effect transistor compare with the DC input impedance of a bipolar transistor? A, they're both low impedance.
B, an FET has lower input impedance.
C, an FET has higher input impedance.
Or D, they are both high impedance. How does DC input impedance at the gate of a field effect transistor compare with the DC input impedance of a bipolar transistor? I see this moving, but I don't want to look at it.
Yeah, don't look at that.
Because I see the answers are coming in. Something is. They're both low impedance. FET has lower. C.
You all of a sudden came up with the answer there.
Yeah, let's answer all the other ones. I'm going with C.
You're going with C. Okay. Any particular reason you chose C?
No, because it was the same as the other one, all the other ones.
I'm telling you, that's not a good strategy.
No, it's not, but it's the only one I got.
Well, chat room, those brave enough to answer are saying C. I'm going to agree with them. It is C.
No way.
Yeah, it is. You want me to do some explaining?
Yeah, go. Yes, please do.
I don't have any pictures
or
a fancy explanation, but I've got just something you can remember maybe by.
Okay.
We're comparing a field effects transistor with a normal bipolar transistor. Well, normal transistors are bipolar. A field effect transistor is a special type. And when we were using tube circuits, the input impedance on a tube is real high. All right?
Mm-hmm.
But on a transistor, it's low. They're low impedance devices. So when you connect something, or you hook the input of, say, a tube to a circuit, it doesn't load the circuit very much. It's high impedance, so it really doesn't load down what you're connecting it to much. A transistor might. If you had a real high impedance circuit, you hooked a transistor to it, it might change the characteristics that circuit is operating at because you've put a low impedance on it. So you will see a lot of times, well, I don't know how much anymore, but it used to be a big point. They made vacuum tube voltmeters, a special type of voltmeter that used a tube in there as an amplifier to drive the meter element. And the reason they use a tube is because it was high impedance, so you could hook it across just about any circuit and it wouldn't affect it.
Oh, interesting.
Where a regular meter, if you hooked a Simpson 260 across some things, it changes the way that circuit's operating because it loads it down. So when vacuum tubes weren't quite as popular, and they, had developed FET transistors with high input impedance, they started making FET voltohm meters. So it worked like a vacuum tube voltmeter. In other words, you could hook it across a circuit to measure something, and it's such a high impedance, it really wouldn't affect the circuit you're hooking it to. And so places where we need a high impedance stage, input stage, we don't want to load down a circuit, and FET is a good choice for that. And so that's pretty easy for me to remember because I had an FET VOM. They use these a lot in some guitar amplifiers and such because, the pickups were made to feed a high impedance like an old tube amplifier. And now if you're trying to emulate that or have the same loading characteristics, you'd use something with an FET so that you're not loading down the pickup on the guitar. It would behave the same as if it was into a tube. Anyway, that's
interesting.
Yeah.
I didn't know that about the tube type meters. I've never seen such.
Really?
Yeah.
Oh, there's some folks that still believe highly in them.
Yeah. Good luck finding one.
RCA used to make a lot of them. That was a real popular one. Okay, I didn't notice what they were saying over in the chat room about it there, but yeah, Heathkit made vacuum tube voltmeters. How many in the chat are extra class licensed holders and are ashamed to show the score tonight?
It's tough stuff, man.
It's
no shame, and if it's been a while since you studied it, a lot of this is not stuff you would use like often.
Yeah.
Well, some of it would be never.
This would be a good thing to know right here.
Yeah, that is for sure.
But as far as putting the P and N types together and stuff like that happening, really all I care about if I've got to put the current in the right side of the diode to get it through, and the other way it doesn't work, but it's on the exam here, so
yeah,
it'd be good to know it if you want to pass.
What is the beta of a bipolar junction transistor? A, the frequency at which the current gain is reduced to 0.707.
B, the change in collector current with respect to the base current.
C, the breakdown voltage of the base to collector junction.
Or D, the switching speed. What is the beta of a bipolar junction transistor? Okay.
I got a guess on this one, but I've never. Maybe.
Well, you want to answer this one?
No, because then I'll have to still answer the next one too.
Well, I just happen to know that the beta is used to describe the gain of a transistor. There's an alpha gain as well. Depends on how you're measuring things. So it's not the frequency that the current is reduced. B, the change in collector current with respect to base current. And if we're putting the signal in the base and we're looking at how much it changes in the collector, usually, it's going to be higher in the collector. So that's would be related to gain. C, the breakdown voltage of the base to collector junction. No, and it's not D, the switching speed. I'm going to say B.
Okay.
And chat
Pretty
room.
much everybody else said B, except for one says it's not C.
Yeah, they're pretty much saying B.
Mm-hmm.
And it is.
Cool.
So the thing to remember there is just if they're talking about the beta or the alpha of a transistor, they're talking about the gain, or it's related to the gain. But I think this is the only question we'll have like this on the exam. So
okay,
there's that. Well, I think it is time, since we're about halfway through the questions in this section, that we'll take a quick break.
Did you fail to dress up for tonight's show? No tie, an old shirt and slacks, a house dress? Well, don't give it a thought. We're glad you came as you are. We just want you to enjoy yourselves.
Spring is just around the corner, and ICOM's new ID52A handheld is now shipping. The ID52A is an industry-first handheld that can send photos over the D-Star network. This radio is perfect for working your favorite bands inside the ham shack or venturing out. The ID52A is now shipping. ICOM's newest handheld amateur radio is a VHF-UHF dual bounder with D-Star and FM dual mode functions. This radio supports conventional FM communications and D-Star simplex, repeater, regional, and worldwide calls over the D-Star Internet Gateway. The ID52A is the first amateur radio with a full 2.3-inch waterfall display and can send photos over D-Star with a connected Android app. Other features include wideband receive with a guaranteed range of 144 to 148 and 440 to 450 megahertz, VHF-VHF, UHF-UHF, VHF-UHF with dual DV mode, integrated GPS GLONASS receiver including grid square location, micro SD card slot, micro USB for data transfer, programming, or charge, and it meets IPX7 waterproof standards. Learn more about this and all the great ICOM radios at icomamerica.com/amateur.
What do you say we give away something?
okay.
An ICOM Ham Crew t-shirt.
You'll look just as good leaving as you did when you got there. I would say to the Ham Fest, but I don't know. I haven't been in one in a couple of years.
I was just at a Ham Fest recently.
Yeah. How was it?
It was pretty good.
Did you wear your Icon t-shirt?
That one?
Yeah.
No, that shirt right there has never been worn before.
Yeah.
It is folded up and put in the cabinet over here. After each episode, we'd have, like you fold the American flag, we have the ceremonial folding of the t-shirt.
Play the Icon tune when we put it in there?
Yeah.
Yeah.
And we put it in the drawer over there. Anyway.
It's been handled a lot.
It has.
It's a nice shirt. I love mine.
Yeah. I've got one like it.
Mm-hmm.
So we're going to give that away along with a swag package, whatever else Jesse can stuff in the box, and send it to a lucky winner.
It's real easy to get in the drawing. All you've got to do is send us an email to hamcollege@AmateurLogic.TV. You don't really have to have a license or anything. You just need a name and an email address. Send us one. If you want to put a note in there, that's great. We love to read them. But if you don't feel like doing it, that's fine too.
Yep.
Incidentally, the emails that come in get purged. They don't get harvested. They go to nowhere else, straight to the recycle bin and emptied. So you no worrying your email getting in spammers' hands.
Did a random drawing of the entries tonight, right before the show.
Okay.
And we've got a winner here.
Who's the random winner?
Well, I got the email that says, please enter me in the contest. Now, that was optional. He didn't have to say that, but he did. And we appreciate it. K9WWW, Rich DePass. He is the winner of this month's ICOM swag package.
Cool. Congrats, Rich.
Yeah, congratulations.
They'll be getting in touch with you soon to get your size and shipping information.
Yep.
So if you want to enter for the next drawing, you didn't win, go send your entry in now. The email box has been cleaned out and ready for new entries for the next month.
Sure is. We got room in there for yours. Which of the following indicates that a silicon NPN junction transistor is biased on? A, base to emitter resistance of approximately 6 to 7 ohms.
B, base to emitter resistance of approximately 0.6 to 0.7 ohms.
C, base to emitter voltage of approximately 6 to 7 volts.
Or D, base to emitter voltage of approximately 0.6 to 0.7 volts. Ooh. It's got to be C. Which of the following indicates that the silicon NPN junction transistor is biased on? I really don't know. C? It's
C.
probably not going to be right.
Okay. But you're going with your strategy on this one.
I'm going to roll with it till it fails me.
Okay, well, it just did.
It sure did, didn't it?
Yeah. It is D, base to emitter voltage of approximately 0.6 to 0.7 volts.
Let me hear that buzzer.
Yeah. You need to hear it again? Yeah. We had a number of C's in there. Not all. There's way more people watching than answering. And I'm not sure what that means. There's an NPN transistor. Measure the voltage between the base and the emitter. When that transistor is biased on, now this is only for silicon transistors, it'd be different with a germanium. You're going to measure 0.6 to 0.7 volts difference between the base and the emitter. Just so happens, this is a quick and easy way to test a transistor in a circuit without removing it. Is you can just measure the base to emitter voltage there, and if it's 0.6 to 0.7, you'll know that transistor's good.
Ah, interesting. Did not know that.
Yeah, handy tip.
What term indicates the frequency at which the grounded base current gain of a transistor has decreased to 0.7 of the gain obtainable at 1 kilohertz? A, corner frequency.
B, alpha rejection frequency.
C, beta cutoff frequency.
Or D, alpha cutoff frequency. What term indicates the frequency at which the grounded base current gain of a transistor has decreased to 0.7 of the gain obtainable at 1 kilohertz? It's not the corner frequency. It's not A. I don't think it's alpha rejection frequency. I don't think I've ever heard that term. So that only leaves me with beta cutoff frequency and alpha cutoff frequency.
Go with C, man. It's worked with me pretty good so far.
Yeah. Well, it has, yeah. I think I'm going to go with it, not for that reason, though, just because I think it's the beta cutoff frequency.
My strategy.
Oh, a little mixed in the chat room there.
Yeah, let's see.
Let's see.
Let's see.
Oh.
Bzz. You got buzz
you
too.
misled me, man. Okay, it's the alpha cutoff frequency.
That's why I'm a dean and not a
Yeah.
professor.
Well, being a professor just really didn't work out for me that time. So. What is a depletion mode FET? A, an FET that exhibits current flow between source and drain when no gate voltage is applied.
B, an FET that has no current flow between the source and drain when no gate voltage is applied.
C, an FET without a channel.
Or D, an FET for which holes are the majority carriers. Depletion mode FET. Exhibits a current flow between source and the drain when no gate voltage is applied. No current flow between the source and drain when no voltage is applied. I'm guessing it's A. I don't
Okay.
know.
Well, I think that's a pretty
What's
good
everybody
guess there.
saying?
Most everybody's saying A.
There's some B's in there.
And it is. And I've got something I can say about that. It's not the full thing, but maybe something to remember by. There's basically two different types of FETs. There's a depletion mode FET, and then there's an enhancement mode FET.
Mm-hmm.
All right, on the enhancement mode FET, if you put a voltage on the gate, then current will flow through.
Mm-hmm.
You've enhanced it by putting a current on the gate. So right, the opposite of enhancement mode would be depletion mode. So
Well, that's kind of what I was thinking when I was, but I wasn't sure of the terminology.
you don't have to have a voltage on the gate to have current flow.
In figure E6-1, what is the schematic symbol for an N-channel dual gate MOSFET? A, 2,
B, 4,
C, 5.
D, 6.
I'm sure you'll probably nail this one right off the bat because you do this stuff a lot.
Yeah.
N-channel dual gate MOSFET.
Okay.
Where's the picture?
I was just waiting to see how many folks were going to answer in the chat room before I showed the picture.
Oh. Oh, so
Yeah.
they've been looking at the book?
Yeah. Okay. Well,
You guys are busted.
yeah. Let's look at the picture. What is the schematic symbol for an N-channel dual gate MOSFET? All right. Well, first, I'm going to say it's dual gates. So that's going to mean it's either 4 or 5 because you see there's 2 gates on those 2 symbols and not on the rest of them. So it's all going to depend on which way that arrow is pointed. One of them it points in, the other one it points out. So I'm going to say it's the one with the arrow pointing in.
4?
4. It's B.
Okay.
Yeah. Most of the people are saying it's B4. And it is.
I figure you probably get that one.
Yeah. Well, I knew it had to be one of the two.
Mm-hmm.
And so if you think about the drawing there,
About
the
the
arrow
in for
is
negative.
pointed in.
Makes sense.
Yeah. Next one. In figure E6-1, what is the schematic symbol for a P-channel junction FET? Is it A, 1,
B, 2,
C, 3,
or D, 6? I'm going to go with 1.
You're going to go with 1.
Yeah. I don't really know I don't know. It's not ones with the dual gates. I know that.
They're mixed in the chat room over there on
Well,
this
good.
one.
I'm kind of mixed up too, so I'm going with 1. So what letter was that?
Well,
I think that's A.
your strategy is working.
Oh, no way.
Yeah.
Well, that was one that looked like, only one that looked like it had a valid junction.
That one tripped up most folks.
Really?
Yep.
Why do many Mosfet devices have internally connected Zener diodes on the gates? A, to provide a voltage reference for the correct amount of reverse bias gate voltage.
B, to protect the substrate from excessive voltages.
C, to keep the gate voltage within specifications and prevent the device from overheating.
Or D, to reduce the chance of static damage to the gate. Why do many MOSFET devices have internally connected Zener diodes on the gate? D, to reduce the chance of static damage on the gate. MOSFETs are very susceptible to static damage, just like CMOS chips and such. You know, when you buy a chip and it's stuck in a little piece of foam, or it comes in a foil-plated bag or a black bag for static-sensitive items. That's exactly the same reason you would have a Zener diode in there, to reduce the chance of static damage to the gate. There's one being applied right there. We have gotten through this section of the exam.
That's the last one?
That's the last one.
All right, well, let's go ahead and shut this down. I need to go lay down, man. I'm kind of beat from all that.
Yeah.
I'm spent.
Yeah, some of these were kind of tough. You know,
all of them were kind of tough.
most of the folks in the chat room were getting all of them right, but some of them tripped up a lot of people, including the two of us.
Well, it's not that hard to trip me up on those because that's really not my thing that much. But I mean, not that much.
Yeah. Well, it's that gets way down into theory on a lot of these right here, below the level of just sticking stuff together on a breadboard and, you know, copying a schematic. That was
Oh yeah,
kind of the
a lot of it's
physics.
pretty hardcore stuff.
Yeah. So that's tonight's questions. What do you say I don't know, maybe just check in the chat room and see if there's anything going on in there
Okay.
we need to mention before we get out tonight. Nancy says tonight was a good learning experience. Thanks. Well,
That's what it's
thank
all
you.
about. Yeah, thank you.
Yeah, we probably learned a few things ourselves.
Oh, I know I did.
Yeah.
I learned something on every one of these.
Mm-hmm. Nigel says he got one wrong. Well, you're tied with the dean and a professor, Nigel. And I think a lot of folks probably got one wrong tonight. Tomei is in there. I've noticed several people with call signs in other countries with us tonight.
Mm-hmm.
Thanks for joining us. What's on the horizon, Dean? What's coming up here? Project-wise or
what I'm working on?
adventure-wise soon? Yeah.
Not too much. Kind of thinking about dating these days. Think about it a lot. I'm hoping I'm going to be able to make it. I want to, but anyway, it's kind of up in the air still. But I want to go.
Yeah.
So I've been thinking about that pretty good bit.
Yeah, I've got, I've already signed up for a ticket. I've got to go ahead and book my flight and do the hotel thing and get all that lined up. I think I'm, at this point, I'm planning on going,
Mm-hmm.
you know.
Yeah, well, I would say yeah for sure, but I've got a work commitment that they keep juggling the date around, and it falls right there with that. So,
Oh, wow.
so I got to kind of see how that pans out.
Did I see that email had booked a room?
Yeah.
Maybe? Yeah.
Yeah.
Okay.
The other thing we got going is we got one of the new ICOM D-Star repeaters, the dual mode repeaters,
Mm-hmm.
and we're working on getting that going. We've got a few paperwork things to finish up getting registered, and then we'll be getting that on the air sometime here very, very, very soon.
Yeah.
I'm looking forward to that. We got a good spot for it.
Mm-hmm. Yeah, it basically comes down to if you're going to register one of those on the gateways, you can't really use your regular amateur call sign, or then you won't be able to use your call sign with just a radio on the gateway. So essentially, you have to have a club call sign. So we've been working on that. We have formed a club, and we've gotten a call sign, and we have applied for a vanity call so that we could drop it from 6 characters to 5. So,
Yeah. And it kind of the call sign makes more sense for
if we get to one, you have to throw them up to 24 different possible choices you might have. And I don't know if somebody's sitting there at the FCC throwing dice or just checking down the list to see, which ones they can assign. But we should know something for that in a few days and then be able to file all our paperwork. I think we've located a frequency and an antenna site, and we've got internet there, and we got power, and we got
the computer,
backup.
OS is set up.
Got backup power, got backup internet, so we should
about ready.
Yeah,
you're real
ready.
Close.
Yeah,
looking forward to getting it going.
Jerry says he's looking forward to the 100th anniversary of the AmateurLogic Soundcheck Net. Yeah, that's coming up. What is it? 2 weeks?
This coming will be the 98th. So we got the third week out.
Oh, 3 weeks. Okay. Yeah, that should be a lot of fun. Nigel's asking, where is your teapot? Right up there, Nigel. We decided not to unveil the teapot tonight. We're going to save that for the next AmateurLogic, since just seemed like more of an AmateurLogic type of thing.
Yeah, that's where it was. So
yeah,
a lot of the audience is the same, but some aren't. Some of the Ham College people might not understand what it was about, but AmateurLogic viewers will. So we'll definitely have it on the next AmateurLogic.
Yeah, and some of the AmateurLogic folks would miss it if we had it here, because there's a little bigger audience there. So, let's see, did we miss anything else? Spike says I was doing well the first 3 questions, but went downhill quickly after that.
Once they changed from C, it's like anybody's guess after that.
It's like as soon as I printed out the questions a couple of weeks ago to get ready for this and looked at it, I said, oh, man, these are going to be tough.
We actually came out pretty well considering what I thought it was going to be, because I thought that we would probably have a good 3-4 buzzers at least, but we only had one each. Yeah,
I think it tripped him up pretty good. He said he's not the same Spike. So, okay. Well, Chip still has his Heathkit vacuum tube voltmeter.
Oh, cool.
Yeah. I wish I could say I still had my Radio Shack FET VOM, and I did. I had it for a good 20 or 25 years, and then finally I dropped it one time too many, and the meter movement broke, and that was it. That's as far as I could take it. I'd already glued the case back together 2 or 3 times previously. I really like that meter. It's nice, and you really need a meter with a high impedance on it if you're working on solid-state circuitry or even tube-type circuitry. Fortunately, most digital voltmeters these days have got a little higher input impedance to it, so it's not much of a factor as it was when we were using old school meters like Simpson 260s and such. And I still use my 260.
Yeah, I've got one. I use it too.
Yeah, some things I just like a good old analog meter. It just they respond quicker. It's easier just to put together what's happening, with what you're working on. If I want accuracy, though, I'm not going to use my Simpson, although it is accurate.
Yeah, something about the meter I don't know. That's
Okay. Marty has the little teapot nursery rhyme stuck in his head now. So, yeah. um,
yeah. Good luck getting that
yeah,
out.
I wish he wouldn't have shared that because now I think you may have started something. I'm hearing it myself.
Oh,
Yeah.
turn on a Milli Vanilli song and wipe that out.
Nigel says in April, Blackpool will be their nearest ham radio rally. Yeah, they don't have Hamfest over there. They have rallies, which is, I guess, about the same thing.
Mm-hmm. It's cool.
Yeah.
What's our nearest Hamfest coming up? There's got to be one coming.
Well, Dayton.
Yeah, that's in May, middle of May.
Well, it's
Would have been the
it's
rain
about
one.
March.
I was going to go to the Rain Ham Fest,
Really?
but they canceled it.
Did they?
Mm-hmm.
Oh.
Said they'll be back next year. Obviously, if something don't change, but yeah, they canceled it. I was going to go for sure.
Yeah. Chip says meters tend to show. Excuse me. Chip says.
I don't think,
I don't
that's
think
what
I
he
can
said.
say what Chip said. Why don't you say what he said?
Chip said meters tend to show trends better than just digits.
Yeah. And quicker too. Yeah.
Mm-hmm.
Particularly if you wanted to check a capacitor. I don't know, a lot of digital meters now have capacitance ranges on it, but
Mm-hmm.
used to checking an electrolytic by measuring across it and then reversing your leads and, watching it kick was always a kick.
Yeah. Or you can plug it into your component tester.
Yeah.
I forget who sent those things to us, but that's been a really handy little thing. I've used it several times.
What's that?
The little component tester.
Oh, I've got mine out that's a fish, and I can't remember the number of it. Fish 2280 or something. I don't remember the number, but mine was, I keep it hung on the pegboard over there without a battery on it because I don't use it that often. But I'm working on an Astron switching power supply that's been kicking my butt for several months now. Well, actually, it's been collecting dust on the shelf because I tabled it for a while till I could get back to it. And I haven't had any luck troubleshooting. Switching power supply is a little more difficult to troubleshoot. And I'm thinking it's a capacitor, and it's probably the capacitor has got a high equivalent series resistance on it now, which wasn't so much a problem in old school circuitry, but it is in a lot of newer stuff, or at least we didn't really talk about it years ago. And now ESR seems to be a big topic. And so I decided I'm just going to pull just about all of these electrolytics out of here. I think it could possibly be, because I've already measured them with the capacitance meter, and they all measured okay. The ones that didn't, I replaced them. But the ESR is another thing you can measure on them, and that little device has been very handy.
Uh-huh.
I'm going to go grab that thing.
I have to go back and look and see who it was that sent that, but it's been very much appreciated. It's a very handy little tool. Oh, yours is naked.
Yeah. This is it right here. Oh, you can't see it because it's green.
Mine's got a display on it.
Well,
Yours just got a big notch.
Well, you hit the number 1 button there.
Oh. Well, maybe.
Look.
I hit the number 1, but it didn't do anything.
Well, did you hold down on the number 1?
Oh, hold on. I know what I did.
There. Okay. Yeah. It's not going to focus this quick, this close in. But anyway, you put your component you want to test in the ZIF socket there, latch it down, and it will determine what you've got connected in there, whether you You got a transistor. I don't know if they can hear me because I'm not near a microphone.
Oh, I can hear you.
Well, tell them what.
Okay, he said you put your component in the ZIF socket right there, and it determines what it is and tells you the values of it.
Yeah.
Yep. It's really nice. ZIF socket. I hadn't heard that terminology in a while. You remember when Intel came out with those for CPUs?
Oh, really? Where you? Oh, yeah.
They had a little arm, you raise it up,
Yeah.
put your chip in there.
They still got those.
Do they?
They don't. I mean, they're not made to be swapped out as quickly as something like this. But yeah, most all of them now, you drop your CPU in and you got that lever.
You got a little arm, you push it down.
Yeah,
it's a
little different. Yeah. But these things are real cheap. And this is, let me tell you what it is. It is a Fish 8840. What did I say it was?
You said it was a Fish something, but
Yeah.
you didn't remember the model number.
Yeah, Fish 8840. If you don't have one of these, you might want to grab one because it's a good, cheap way to check ESR and a whole lot of other stuff. And for about $15, you know, it's hard to go wrong with it. Oh,
Yeah.
I see what you did.
Yeah, scroll.
Yeah. Okay.
You said hit that first button, so that's what I did. I couldn't see it.
Yeah. Okay. So with that, is that a 9-volt Duracell?
Is it been
Let's
leaking?
check. It is not leaking yet.
Not yet, but it's just a
Not
matter
yet.
of time.
It expires in 2023. That means it should have been leaking about a year ago. I don't know. I really hadn't had the 9 volts leak as bad. This is the last 9-volt Duracell I own. It may be the last Duracell I own altogether.
I went to Costco the other day and was looking for some of those batteries. I think it was Arnie that said that they were good, and I forget the name of them now.
Well, they're made by Duracell.
Yeah, but I was looking at. I was going to get a picture of the box. It says,
yeah, okay.
I think it says like guaranteed for 20 years or something like that, or 10 years, 20 years.
Thanks for being here with us, and do your studying and take your test.
And see what you can do.
Yeah, but don't guess C on everything. that won't work out in the long run.
See you next time.
7-3.
7-3, everybody. The frequency at which the current gain is reduced. A. Well, look what I found. How about this shirt?
An ICOM. There's your blooper. An ICOM Ham Crew T-shirt.
Yep. It looks just as good as you leave.
This month's ICOM swab. Let's look at the picture. There we go. It's the picture's not wide enough to cover the screen. We can do little shadow figures over there or something.